welcome to Maths Appeal. I'm Susan Okereke.
And I'm Bobby Seagull.
And we, the Maths Appeal team, really want to help and get everyone involved in doing maths. We are two maths teachers that are passionate about getting everyone to love and to do maths.
And we know that a lot of people can be scared, have a phobia of maths. So I think our podcast is trying to help sort of almost like rid the world, at least our podcast listeners, from maths phobia.
And we've also, luckily today, we've got a special guest, Dr. Tom Crawford, also known as Tom Rocks Maths. If you might know him from YouTube and the like. And he's going to talk to us about his love of maths and also his work as a maths influencer as well.
So he's been a good friend of ours, and actually we worked on some fun projects with him, such as like a maths appeal. In fact, it's called Tom Rocks Maths Appeal collab during lockdown. YouTube, GCSE videos. We've even taken part in a fun countdown video. And also, what's exciting is this is one of the first times we're speaking to Tom since he's got like a silver award. I think a silver award for like 100,000 YouTube subscribers. So Dr. Tom, as I call him, is going to be doing some maths problems for us very soon.
Brilliant. And so, as you may know, if you've listened to other episodes, we are focusing on maths thinking and problem solving. So we kind of are in the action of applying the maths that we know and using it to work out problems.
And we know actually as teachers, it can be tricky to teach problem solving because you can teach students a formula, how to apply a formula, but problem solving is almost like a more abstract way of approaching things. So it's not the easiest thing to teach.
And we also want to demystify the idea that you have to do maths on your own. We want to show that it's collaborative. You can do it as a community. It's a safe space to try. And it's also a thing that you can do that can be really fun.
So we will present you with a problem, but we also have a structure in tackling the problem. So the way we like to think about it is like before doing the problem and then while doing the problem. So before doing the problem, we always think about like, the emotional side. How do you feel when you see or hear the problem? Then secondly, like thinking about, does it actually make any sense to you? Are there any questions you've got about the problem? This might be one that you pose to your teacher, or if you're doing it by yourself or with a partner, to themselves or to yourself. And then finally, like what maths topics, maybe syllabus topics, are actually being covered in this particular question.
And once you've kind of set it up in your minds, you've done the pre-questions, you then think about, right, actually, how do I work this question out? And some of the questions you ask are, what facts do we know from this problem? What rules and formulas do we need to use to kind of solve elements of the problem? What can we then derive? So what can we work out? And how does that help us work out the answer to the overall question?
So Susan, I feel like we're getting to that stage where, are you ready to tackle this week's problem?
Ready!
Ready. Grab a pen.
Yes.
Grab a paper.
Yes.
Grab a phone.
Yes.
And we'll get right into this after a little break.
So, the problem for today's episode, it's a lengthy one, so do make sure you've got a pen and paper ready, okay? And it's for those people who love a bit of cooking. So there's a recipe one here. So, first things first, here are the ingredients needed for 16 biscuits, okay? So you need 175 grams of butter, 75 grams of sugar, and 250 grams of flour, okay? Anna, who is in the problem, she has in her cupboard 500 grams of butter, 300 grams of sugar, and 625 grams of flour. Work out the greatest number of biscuits Anna can make. I'm going to repeat this, okay? So pen and paper's ready. Make sure just have a quick check of what you've got. Here are the ingredients needed to make 16 biscuits. 175 grams of butter, 75 grams of sugar, 250 grams of flour, and Anna, or I should have said Bobby, really shouldn't I, has 500 grams of butter, 300 grams of sugar, and 625 grams of flour. Work out the greatest number of biscuits Anna can make.
Getting peckish. So we will get stuck into solving that in a jiffy. But while you're having a little think, we want to actually get to know our guest a little bit better. So I'm going to introduce our guest. I'm going to read his Twitter bio. Twitter bios are always interesting because it's sort of like they're trying to distill their entire incredible life into.
Is it 140 characters?
Yeah, I don't even know how much. I don't know how much it is for the intro, but it says here, mathematician at the University of Oxford and St Edmund Hall, numberphile, naked mathematician, a YouTube creator on the rise, a lover of rock music and maths tattoos. Dr. Tom Crawford. Round of applause. Welcome. Dr. Tom.
Tell us, Tom, is it all right if you tell us in your own words a bit about like what you do, especially what you do kind of at Oxford, and all the external stuff you do as well.
Love to. So my main role at the university is to teach maths. So I mainly look after the first year and second year undergraduate students, which is a lot of fun. As you can imagine, they're quite a clever bunch. So certainly very challenging, but in a very fun way. A really nice group of students to teach. They all work very hard. And then when I'm not teaching the students, then as you've mentioned, I do lots of YouTube-based things. So my channel, Tom Rocks Maths, as Bobby said, and thank you very much, just reached 100,000 subscribers. So I got my silver play button in the post from YouTube literally last week. So that's just come through, which is awesome. So a huge thank you to everyone that helped me get there, including you guys. I'm also on the Numberphile YouTube channel, which if we've got any hardcore mathematicians listening in, will probably at some point have stumbled across a Numberphile video on YouTube. So we got really excited. It was about 2 years ago now when the Numberphile channel reached pi million subscribers. So, 3 million was good, but it was like, you want the 3.14 million. You want to get to pi.
That's real maths there.
So, yeah, lots of YouTube videos and then lots of talks in schools, lots of events. Basically, any opportunity I have where I can talk to people who will listen to me, trying to do some interesting stuff with maths. Very similar to what you're trying to do with the Maths Appeal podcast, right? We're just here to hopefully showcase how fun our subject is and help people enjoy it as much as we do.
Can you bring some of your knowledge? I think you're going to talk to us today about maths modelling, which I think is something that everyone should kind of know because it's maths in action, isn't it?
Just to clarify, this is Tom does some modelling of tattoos, which you'll find out more about later. But this is your actual mathematical modelling, as opposed to modelling of tattoos, which we want to know about as well.
You're a supermodel maths modeler. Okay.
the compliments just keep on coming today. Yes, this is mathematical modelling, was what I was very keen to share with you all today, because it's a big part of what I do in my research. And in particular, during my PhD, where I spent 4 years in Cambridge, and I was looking at the spread of pollution in the ocean. Wow. So I think, hopefully, we can all agree it's quite an important issue, the plastic pollution in our ocean. And what we were trying to work on was to say, can we use the tools that we have in maths to actually help us understand where the pollution goes in the ocean? So you imagine having pollution in a river, the river flows to the ocean. Where will it actually then go? There's a very big wide ocean that it can end up in. But if you have pollution leaving, let's say, the River Thames in the UK, will that pollution end up in the Pacific Ocean? Will it wash up on the shore somewhere in Asia? It's an interesting question. How does that pollution spread?
And you're using maths to do that?
Exactly. Yeah.
Okay,
mathematical modelling.
Big. Okay, right. So how? This is huge. How?
Well, it kind of comes down to the power and the versatility of maths, and this is why I love it so much, because you can basically apply it to anything. And I'm very appreciative of your excitement that we can use maths to solve this problem around pollution, because ultimately you just need to turn your problem from words from the real world into equations. And maths gives you the tools to do that. So whether it's figuring out a recipe and how many biscuits Bobby/Anna can make, it's the same thing. It's saying, okay, there are certain things that control how the pollution moves in the ocean. Right. Yeah. Ocean currents, for example. Maybe. Can you give me any others? What else might affect where the pollution goes?
The weight of the pollution, the weight of the actual thing that's that is the pollutant, if you know what I mean. So whether it's a bit of paper or it's a like metal bottle or something.
Absolutely, yeah. If it's really heavy, it's going to sink almost immediately and go nowhere. But if it's very light, if it's something like a microplastic, so small we can't see it with our eyes, it really can travel anywhere. It could accidentally be swallowed by an animal. It can float. It could sink very slowly. There's all kinds that can happen. Yeah. Maybe the wind, the weather could have an impact. There's all kinds of different factors. And so what you're trying to do when you're modeling this is to work out which of these are the most important factors, and can we then construct an equation or a set of equations that's going to describe the problem, and then can we solve it? And the solution will tell us where the pollution will go, or that's the idea.
So this is like whenever a kid asks, why are we learning algebra? We can actually say, to work out where pollution goes wherever you are to other parts of the world. And it's about setting up and formulating equations. And through those equations, we can start to make predictions, I guess. That's the key thing, isn't it? Because you can't just do that with just random numbers. It's about changing things, isn't it? It's about being able to think about variables and putting, shifting things if you need to.
It's exactly that. Yeah. I was about to say it, and you stole the words from me. It's the variables. You've nailed it, right? It's saying, okay, so we know the fixed numbers. We know this pollution weighs this much. We know this ocean current moves at this speed. So you can work with numbers to get an answer. But then what you want from a mathematical model, and this is where they're powerful, is you want to then be able to change those numbers. And that's where you need a variable. So instead of having the number 3, it now becomes x. And you need to input what the value of x is. And that's where you need to be able to work with algebra, to work with letters, to work with mathematical equations, to be able to really solve these things. So you do eventually plug in the real data at the end, but of course the data is going to differ if you're looking at the River Thames in London. Maybe you go and look at the River Mississippi in the United States. All of the variables, the values of things are going to change. And so your model needs to be able to cope with that, which is where the algebra comes in. Something I mentioned at the very beginning about mathematical modeling and looking at what variables might affect the spread of this pollution, that requires specialist knowledge. Okay, so you would go and speak to maybe geographers, maybe climate scientists, maybe oceanographers who have more of a knowledge of the ocean environment. And they can help you as a mathematician to decide what variables, which are the most important factors that are going to affect the problem that you're trying to solve. And I think we saw this a lot recently with the disease modeling in the pandemic. So there was a lot of talk around mathematical modeling being used to help us make decisions, to help us decide what should and shouldn't happen in different countries and different situations. And that was done using maths, but it was really important that you had the input from medical professionals telling the mathematicians what you should look at in the first place. And I think it was really nice to see the teamwork between mathematicians and medical experts sort of working together to try and help us through that period.
Yes, that collaboration. With Susan and I always talk about people imagine maths as a solo activity, like some professor like Dr. Tom sitting there with his pen, but actually it's a very collaborative thing that involves people
working together.
It's sort of it's not what people expect mathematicians to be the ones leading discussions and chatting to many people from different fields.
And that leads us really, really well onto the solution of our problem today. So it's not quite as kind of huge as your pollution model, but it's still an important one because it's to do with biscuits, and that's pretty important. So I'm going to review our problem for today, and then we're also going to ask you, Tom, is when we kind of go through it to share your solution too. So just as a reminder, the problem. Here are the ingredients needed to make 16 biscuits. 175 grams of butter, 75 grams of sugar, and 250 grams of flour. Anna / Bobby has 500 grams of butter, 300 grams of sugar, 625 grams of flour. Work out the greatest number of biscuits Anna can make. How did we feel reading this question or hearing it for the first time? So Bobby, I'll go to you first and I'll ask Tom.
Hungry. These questions are dangerous in exams because if if you're a student, you're in the middle of an exam and you're working out something, and suddenly like, I feel peckish. Cheeky examiners.
Focus.
I think I just felt like, okay. As a student, I always find these questions a bit tricky, these proportion, because it wasn't like a straightforward method you can just apply.
What about you, Tom? How do you feel?
Yeah, kind of the same as Bobby. Like I sort of looked at the numbers involved, and the first thing I was thinking is, do they divide nicely? Right. So I'm seeing like lots of numbers ending in 5, and then I'm seeing 16, and I'm like, they don't divide nicely. This is gonna require something else.
Yeah, I mean, that's the same. I was like, because it's not like, here's 16 biscuits, how do you make 32 biscuits, or how do you make 8 biscuits? It's like, you have to really think about this. And also what's kind of a bit more tricky as well is we don't know, it's not in proportion how much they've got of the extra stuff. So you're like, it's not going to be the same amount for each one. So it's you do have to think quite like heavily, which is, I think that's why it's a kind of a great question, because actually this is probably it's quite useful. It's like real life. How much flour do you have? If you want to use up all the flour to make biscuits, actually how many can you make based on what you have? So it's I quite like it, but it isn't that nice. Any questions that came up? Do you feel generally quite happy about understanding what you have to do? No other like assumptions that we have to make? It's quite straightforward, really, isn't it?
So I think what you've mentioned there, Susan, about real life, actually, once I thought about it in that context, I found that to be really helpful. So when you were saying, like in real life, you'd be like, oh, okay, here's the recipe. But then you'd be like, oh, but I've only got this amount of flour. And that's, or whatever it is. And it's like, usually there's one ingredient that you have like a limiting amount of. So I think here, actually framing it as though you imagine yourself in the kitchen making biscuits actually gives you a really nice way of getting into the maths problem and helps you actually solve it.
As opposed to just thinking, what's the procedure? You're like, well, actually in real life, what would I do here? And then you just kind of like work through the systems of like what you'd kind of do. Because this problem, if we think about the maths of it, it's proportion, isn't it? It's like one thing increases, the other thing increases, how many things fit into it. So you're just thinking about, and also for each of those different ingredients, as something increases, they all have to increase by the same amount. And if you don't have the right proportions, you can't make a certain amount of biscuits. So having more flour, if it's a lot more flour, then you can't make a biscuit just from flour. So it's thinking like that. So we go into our solutions then. So we've done all our feelings. We generally understand the question. We get what we have to do. We know it's about proportion. Right. So what can we start deriving? Because I know there's a variety of ways of doing this question. That's kind of why I picked it. So how did people do it?
Yeah. So like initially, I think I try, again, like Dr. Tom, I think I tried to think, do the numbers fit in neatly? And I was like, it doesn't. So initially, actually, the way I finally got to the answer was different to my initial approach. My initial approach, I think I tried to work out how much per biscuit. So how much butter per biscuit, how much sugar per biscuit, how much flour per biscuit. That was my initial approach. Although I think I abandoned that approach and went for a slightly different one later on. But that was my initial way.
Just want to jump in and let you know that this problem is a GCSE calculator question, so you need a calculator to do this. So I mean, you don't need a calculator, but it would be much more helpful if you've got a calculator, and it'd be expected for you to use one. So I probably should have said that earlier, is a GCSE calculator question. So finding one biscuit and then scaling up is totally feasible. So how would you found one?
Yeah, just like 175 divided by 16.
Yeah. So the numbers aren't that nice, but then once you've got one, you've then got to how many of those one amounts could fit into the extras that you have. Yeah. I did it slightly different. I looked at the values and for 16 biscuits, and then I was like, right, the amount I have, how many of those 16 biscuits that value like fit into the amount I have. So I did, the first thing I worked out was for butter, for 16 biscuits 175 grams, but I have 500 grams. How many of the 175 fit into the 500? And that was 2.8 something. I was like, oh god, that's terrible. But then I was like, also that represents a number of 16, so I multiplied that by 16 and got something like 45.7, which is 45 biscuits. And then for sugar, I did the same idea. I took 75 grams as our 16 biscuits, and then I took through 300 and divided the 75 by that, and that gave me 4. So that's 4 batches of 16. So I multiplied that by 4, which gave me 64 biscuits. Is everyone happy with these numbers, by the way? Mm-hmm. Just checking. Yeah. And then for flour, I then sort of took my 250 grams of 16 biscuits, and then 625, divided that by 250, which gave me 2.5 batches of 16 biscuits, which then gave me 40 biscuits. And so knowing that there was like 45 potential, 64 or 40, but for them all to be able to be made, you have to go for the smallest value, don't you? Because then you've got everything. So it's 40 biscuits. Did everyone get 40 biscuits?
Sure did.
Okay,
I did it completely differently, but I
What
got
did
40
you do?
biscuits.
What did you do? What did you do?
Okay, well, so I started the same as Bobby. I was like, right, let's work out how much butter, sugar, and flour for a single biscuit. So take the given numbers on the recipe, divide each one by 16. And that's what I was saying about the numbers not being nice, because immediately I was like, well, I don't want to do 175 divided by 16 in my head. Like, I don't know how to do that in my head, because I didn't know you could have a calculator, because somebody didn't tell us you could have a calculator.
Oops, sorry about that.
So I was like, okay, no, I'm glad you didn't, because it made me think about it in what I think is maybe like a slightly cleverer way of trying to do it, or like at least an alternative approach, let's say. So you don't necessarily need to know that. So when I was saying about how it links to real life, I was thinking if you're, for example, trying to do this in real life and you've got like a tiny bit of butter, it doesn't matter how much flour and sugar you've got.
Yeah.
You're going to be limited by the amount of butter you have. So when I looked at the numbers, I thought, okay, so if I've got 300 grams of sugar, that, as you've said, Susan, that was 4 lots of the 75. So I can make 4 batches of 16. So I was just like, I can make a lot of biscuits with the sugar. I've got quite a lot of sugar. If I look at the butter, the number, I didn't work it out exactly, but it's 175, 350. You can't quite get a third one, because that would be 525. So I was like, it's somewhere above 2.5 to 3. Again, because I was trying to do this without a calculator. But then for the flour, it actually fits quite nicely, because you've got 250 plus another 250, and then you're left with 125.
Half.
And that is quite easy to spot. Oh, that's half of the batch. So I could see from flour, you could get 2.5 full sets. And the other two numbers were 4 and was something else that was nearly 3. So I could see straight away, flour was where, flour is the problem. I don't have enough flour. That's going to limit where I'm going to go. So then I could sort of say, right, well, I can do 2.5 batches. What's 2.5 times 16?
So because of you, the first bit, you just didn't even bother working out the other biscuits. You're like, I know that what I need is the flour. Very, good. See, I love this.
It's helpful when you don't have a calculator sometimes.
I mean,
yeah, it is. It is.
And that was a part of my plan. That's why I didn't give it to you, Tom. So thank you. Wow. Well, we'd also love to hear your people listening, your solutions. Did you do it different to the way that we did it, or is there a thing that we're not thinking about? So if you do have any ideas and want to share them, please do on Twitter or on Instagram, or even you could email us with your solutions. We'd love to kind of see how you've done that. And so now it's time, as we're coming closer to the end, now is our time for our Bobby's Maths Fact.
Every episode we do a maths fact, sometimes connected to the discussion or topic, sometimes not. This one tenuously connected. Temperature. Susan, in America, what's the scale that they use? I always get the answer. The scale they use to measure temperature.
Fahrenheit.
And then Dr. Thompson's here. What's the scale they use in the UK to measure temperature generally?
Celsius.
Celsius, yeah. That's not a trick question. So in my mind, so normally we have, like, if I say it's like 30 degrees Celsius, in America they're like, it's much higher, isn't it? It's like 85, 90. It's a much higher amount.
Scale.
But the cool thing is, and again, this fact here is something that has come up as a university challenge starter question. And what they say is, at what point on the Fahrenheit and Celsius scale are the temperature degrees equal? Do you just happen to anyone know off by heart, or do you want me to enlighten you?
I've got no idea. I don't know. Because I know there's something to do with 32 degrees or something for the conversion, but I don't know the conversion at all.
Yeah, I was like, I know 0 Celsius is that like minus 30 Fahrenheit? Mm-hmm. Is it something like that? So I'm thinking it's got to be a bit more than that. Yeah, maybe like 12 Celsius.
Ooh, we went, I think the other way, add 12, it's minus 40. So minus 40 Celsius and minus 40 Fahrenheit are exactly the same. So that's where America and Britain, we shake hands and go, there we go, we agree on our temperature scale. The rest of it, we don't agree.
Oh wow, that's mad.
And there is an algebraic way that we will share on Instagram of being able to work it out. I think you need to set up Fahrenheit is Celsius times 9/5 plus 32.
Wow.
Celsius is Fahrenheit minus 32 times 5/9, and you can just use X instead of Celsius and Fahrenheit and then solve it. And that actually gives you minus 40. So we'll share a diagram of this for you. But that's quite cool. Minus 40 is where Celsius... This is a good pub quiz question as well.
Great. So if it's a
I
university
wonder
challenge.
whether it's ever been minus 40 in the US and minus 40 in the UK at the same
At the same time.
Never thought.
Wow.
Probably not.
No,
Has the
'cause
UK
also-
ever been minus 40?
Alaska.
Yeah, so I bet it's happened in the US, but we probably never had it in the UK, have we? I don't think we'd have ever had minus 40.
That's interesting. Yeah, I mean...
One for the
if you have-
listeners.
Yeah. Well, if you have the dates, if you have the data set, share it with us. Why not?
Well, I think that's about it. Well, thank you so much, Dr. Tom, for joining us. Dear listeners, if you want to send us any maths facts or more problems, get in touch at Maths Appeal on Twitter or Instagram as well.
Or you can email us on mathsappeal with the number 1 at gmail.com.
We'd love for you to help spread the word. It helps if you give us a 5-star rating. Tell your friends about the podcast. Genuinely, we're really grateful.
And you've been listening to Maths Appeal with me, Susan Okereke, and Bobby Seagull, and our
Dr. Tom!
our fabulous guest, Dr. Tom Crawford.
The music's been composed by Kelly Okereke, the image design by Calix Davis. The producer is the wonderful, as always, Jenny Nelson. And we will see or hear you in episode 5. We're going to solve some more maths problems together.